Okay, so this is 2012, the sample paper, and it is question 7. Okay, so I was asked to fill in the last 3 rows of data have not been included in the scatter plot, insert them now. So that would be 1760, 1730, 1958, and they're just drawn in here. Then I'm asked to calculate the correlation coefficient, and I got 0.62324. What can you conclude from the scatter plot and the correlation coefficient? There is a moderate positive correlation between number of years in education and the income. As one increases, so does the other. Okay, so then use your line, add the line of best fit to complete the scatter plot. So I just drew my line of best fit in. Use the line of best fit to estimate the annual income of someone who has spent 14 years in education. So I went up to 14 over and I got 40,000. Okay, the next thing that I have to do then is, sorry, this is not a bit funny. Is I have to take suitable readings from your diagram or otherwise calculate the slope of the line of best fit. I just took 2 particular points from my line. They were 1440 and 1335, and I got my slope to be 5. You could have also just done the rise over the run. And explain how to interpret this slope in this context. So it implies that for every 1 year of extra education there is corresponding rise in 5 units. So basically for 1 extra year you get €5,000 extra. And then the student, so list 3 problems regarding the sample and how it was collected, that we might want to make the result of investigation unreliable in each case. So I just said calls made in the evening. Okay, so that could affect the type of workers that are actually being asked, because they might not actually get everyone that works in the evening. Some people could be on shift work. Time of day mightn't actually suit everyone to answer a questionnaire. The telephone directory shows landline numbers only, so not everyone has a landline. And also we could say if the survey was intended to represent the whole country, then using double numbers will mean that only the data is unrepresentative. We won't be getting an entire view of the entire population. Here I have if 6 employees are selected at random from the population, what's the probability that exactly 4 of them had earnings of more than 1280? So this is probability again, so it's our Bernoulli trial, because we're getting out of 6 of them, so only exactly 4 of them had this. So basically I read off, so I have my 1280 is the lower quartile, so we know that's like 25%. So above 1280 would have to be 75%, and then I get my figure. So it's 6 choose 4, and I have 0.74 to power 4 and 0.25 to power 2, and I get my answer is 0.296625. And then the next one, so I have described the expected distribution of these sample means. Your description should refer to the mean shape of the distribution and its mean and standard deviation. Okay, so I got my mean is 22.05, my standard deviation I get is 0.0752. And how many of the sample means do you expect to be greater than €23? So I want X is less than or equal to 23, so then I get Z is less than or equal to 23 minus 22.05 all over my standard deviation, which is 0.752, and I get that score is equal to 1.26, but when I look at it in my log tables I get 0.8762, and then I get 1 minus it because I want to be greater than 23. So I currently have everything that earns below €23 an hour, so I get 0.1238. And how many of the sample means? Okay, so we have to remember that our distribution, we've actually sampled 1,000 people. So it says this at the start of the question, and then we just multiply 1,000 by this and we get 124 people.